Betelgeuse. The unstable red giant on the brink of explosion? Betelgeuse is extremely unstable and close to exploding. No, it is about to. That's the thing. It might occur tomorrow or during this broadcast, and it would shine like a second sun in the sky. The James Webb Telescope recently discovered a significant 250% increase in the luminosity of Betelgeuse. Positioned as the red giant star on Orion's back shoulder, this strange behavior has sparked anticipation of a rare event. Some experts speculate that this surge in brightness may indicate Betelgeuse's impending supernova, but the exact timing remains a mystery. Some believe it could happen soon. Come along with us as we delve into the mysteries of space and explore the fascinating details of this colossal star. Betelgeuse. A star with the potential to revolutionize our understanding. Despite the fact that its name may not be widely recognized, you've likely admired the bright red star glowing on Orion's shoulder, a constellation familiar to many. Betelgeuse's size is staggering. If situated at the heart of our solar system, its outer layers would stretch all the way out to the orbit of Jupiter. This gigantic star, often visible to the naked eye, continues to amaze us. Unlike most stars, Betelgeuse is noticeable for its gradual but substantial changes in appearance over time. Because of its closeness to our galaxy, it is classified as a semi-regular variable star, meaning its brightness fluctuates periodically, progressing toward a final collapse that will result in a supernova. Star under close observation. In recent years, Betelgeuse has captured even more attention due to unexpected brightness variations. Among them was a dramatic spike in brightness observed on May 20, 2023. Enthusiasts tracking Betelgeuse through social media reported an astonishing 142% increase in brightness, followed by an updated report indicating a 15% rise. Andrea Dupree, an astronomer at the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse is now the seventh most brilliant star in the sky, climbing up 3 spots from its usual position at number 10. From the southern hemisphere, Betelgeuse is an unmistakable sight early in the evening, shining from Orion's shoulder. Dr. Sarah Webb, an astrophysicist at Swinburne University of Technology in Australia, emphasizes Betelgeuse's significance, providing an extraordinary chance to observe the final stages of a massive star's life cycle. This offers valuable insight into the behavior of red giants before they explode as supernovae. When Betelgeuse eventually explodes, it might shine so brightly that it could cast nighttime shadows for roughly a week. This possibility excites both amateur astronomers and professionals eagerly awaiting the event. A rare and unpredictable event. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Padaro Astronomers and Astronomy Club, notes that Betelgeuse's unpredictable fluctuations have intrigued observers for centuries. The star's brightness cycle currently lasts around 130 days, much shorter than its usual 400-day period. These rapid changes give astronomers a rare opportunity to investigate unusual stellar behavior in its final stages. Betelgeuse's unusual behavior began in 2019, after the star expelled a significant portion of its outer atmosphere. The brightness fluctuations are abnormal, leading to speculation about whether it might soon explode as a supernova. According to a study led by Dupree and researchers from Harvard and the University of California, Berkeley, it will likely take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle. Since the Great Dimming event, Betelgeuse has displayed unpredictable behavior in both light emissions and radial velocity. Despite this, the star remains a massive red supergiant, undergoing the rapid final stages of its development. Prior to Betelgeuse exhausting its fuel, its core will collapse under its own immense weight, triggering a supernova explosion that could rival the brightness of an entire galaxy. However, the exact timing remains uncertain. Dr. Grauer, an associate professor of astronomy at the University of Portsmouth, emphasizes that forecasting supernova events is incredibly challenging due to the complexities of stellar evolution and the absence of detailed data from past explosions. What happens next? Currently, Betelgeuse is undergoing fusion processes in its core, moving through elements such as helium, carbon, oxygen, silicon, and iron. In the end, as the star converts helium into carbon, a process that spans thousands of years, it will eventually begin fusing even heavier elements. This process will continue until fusion is no longer possible, causing the core to collapse and potentially resulting in either a black hole or a neutron star. Some speculate that Betelgeuse's explosion could be imminent. However, historical records suggest the star has been expanding and becoming redder over the past 2,000 years, implying that the supernova might still be a long way off. NASA estimates that Betelgeuse won't explode for another 100,000 years, reassuring us that it's unlikely to happen in our lifetime. Despite this uncertainty, Betelgeuse continues to captivate scientists, driving advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us that while we might not live to see Betelgeuse explode, its unpredictable behavior offers valuable opportunities for astronomers to study the final stages of a massive star's life cycle. For discovery, by keeping an eye on Betelgeuse's changes, we might find new insights that help us move forward in the exploration of the cosmos. It's essential to keep in mind that when observing Betelgeuse, we are actually looking into the past, beyond the light that reaches us. Given that the star is over 600 years old, Betelgeuse may have already erupted, but we haven't seen the light yet. Despite this possibility, it is not even close to certain. Astronomical history is full of surprises, as illustrated by the unexpected supernova of a huge blue star in a different galaxy. Before that, in 1987, scientists believed that only red supergiants could go supernova, demonstrating how quickly our understanding of the universe can evolve. Researching Betelgeuse and other significant stars enriches our understanding of stellar phenomena. Although Betelgeuse's explosion may be a distant event, its current behavior is still intriguing. The way stars pulsate and change over time is truly amazing, and Betelgeuse's rapid oscillations give us a rare opportunity to examine this phenomenon firsthand. Despite being far brighter than expected for a star of its type, Betelgeuse may eventually return to its regular 400-day cycle, though recent observations suggest it is struggling to do so. Some scientists believe the star may be nearing the end of its primary phase of carbon burning, moving toward the creation of heavier elements like oxygen and magnesium. If this is indeed the case, experts predict that a core collapse could occur relatively quickly, resulting in a supernova within just a few decades. Determining the exact stage of Betelgeuse's evolution remains a challenge, and there is still much we don't understand. While the prospect of witnessing Betelgeuse's explosion is thrilling, the timing is unclear. The carbon fusion phase could last up to 1,000 years, and some studies suggesting an impending explosion are not yet published. However, if it does happen in our lifetime, it would be a significant and unmistakable event, even visible in daylight for weeks. When the explosion occurs, the first signs will be subtle but unmistakable, as neutrinos wash over Earth and high-energy photons escape from the expanding cloud of debris. Betelgeuse will gradually increase in brightness, reaching a peak between 10,000 and 100,000 times its typical brightness in just a week. This remarkable spectacle will astonish anyone fortunate enough to witness it. The remnants of the star could appear as bright as half or a quarter of the full moon, casting dramatic shadows on Earth. The effects of Betelgeuse's explosion would remain visible for about 100 days, providing astronomers with a rare opportunity to study the aftermath in detail. Fortunately, because Betelgeuse is so far away, its explosion won't pose any threat to life on Earth. Amateur astronomers with binoculars and telescopes will be able to observe the event safely. A supernova of this scale would undoubtedly capture global attention, sparking renewed interest in astronomy. Historically, supernovae have been interpreted as omens, and Betelgeuse's demise would likely evoke strong reactions across cultures. Astronomers also believe that such an event could rekindle curiosity about space exploration, bringing the cosmos back into global public consciousness. Betelgeuse is not the only red supergiant in the galaxy. Other stars like Eta Carinae might explode before it does. Statistically, our galaxy should witness a supernova every 50 years, yet we have gone nearly 400 years without observing one. However, remnants from past explosions suggest that another occurrence is long overdue. Betelgeuse has already surprised astronomers with significant events, such as its remarkable dimming in 2019. This sudden decrease in brightness baffled scientists, leading to speculation about an imminent supernova. Despite the star's brightness returning to normal in 2020, the cause of the dimming remained unclear until further observations revealed its true nature. This event, which was easily visible to skywatchers and amateur astronomers, provided scientists with valuable data to improve their understanding of Betelgeuse's behavior. Researchers rely on high-tech observatories, such as Hubble, to study the mystery surrounding its dimming and potential explosion. Betelgeuse has captivated astronomers worldwide, making it one of the most anticipated astronomical events in human history. Unlike our Sun, Betelgeuse is a much larger star with a shorter lifespan. Eventually, it will become either a neutron star or a black hole, depending on what remains after the explosion. However, experts caution against assuming an imminent supernova. More likely explanations for the dimming include convective cell activity or dust clouds. Observations made with the Very Large Telescope in Chile, led by astrophysicist Miguel Montargis, revealed that a dust cloud formed in late 2019. This cloud, part of a surface-wide eruption, likely contributed to Betelgeuse's dimming. The outburst released more mass than typical solar ejections, offering a glimpse into the turbulent activity of the star. The likely cause was gas plumes rising through Betelgeuse's surface due to its pulsation cycle. While the exact reasons remain unclear, this incident provided an unprecedented opportunity to study the star's internal processes. The research team performed over 10,000 simulations, all of which supported the dust cloud theory. Their findings help explain Betelgeuse's recent behavior and shed light on its transition toward a supernova. Despite the remaining mysteries, ongoing research and observations will continue to enhance our understanding of Betelgeuse. The star's periodic fluctuations in brightness remain an exciting area of study for international astronomers. While Betelgeuse may eventually explode as a supernova, one thing is certain: it will continue to captivate humanity for generations to come.